All right, this is AP Calculus Lesson 5-1. We are going backwards finally today. So basic antiderivatives. We have done derivatives, now we are doing the antiderivatives. Just a note for everyone also, this is our last unit of multiple choice. Unit 6 is going to be free response. All right, so let's kick it in with derivatives. So if I have a powerhouse, you are in powerhouse. What are the steps? There's 2 steps for powerhouse. Do we remember them?
Multiply the exponent down.
Yep, so multiply down. And what was this last step?
Subtract 1 from the exponent.
Exactly. And I'm just going to say subtract 1 to keep it simple. We know what that means. Subtract 1 from the exponent. Here's the antiderivative. Here we go. The first step, what would you guess it would be?
Multiply up.
Ah, multiply up.
No way.
So it's actually reversed of the steps and reversed of the operations.
Divide.
So this is kind of the typical inverse function. Inverse function switches the steps and switches the operations as well. So instead of subtracting 1, I'm going to add 1.
Oh.
And that means add 1 to the exponent, just like this was subtract 1 from the exponent.
Okay, you guys ready? I don't hear anyone talking.
And now after you've added 1 to the exponent, that same number that you've added to is going to be divided down.
So you still divide down.
So instead of multiplying down, it's divide down. And then here's the trick. There's a little trick now. There's a hidden step 3, and it's just because of the derivative of any constant is 0. We remember that rule? Derivative of a constant is 0.
0. Yeah.
But what happens when we go backwards? What if there was a constant? We don't know if there was or if there wasn't. So we always have to do this extra step. So we'll do a little star here. Extra step. Extra step, and it is add a C. And that C just stands for there is a constant. That the constant might be 0, but there is a constant that we always need to remember when we go backwards. And this is true for every time you take an antiderivative, unless it's a definite and you can find what it is. So generally speaking, you will always be adding a C for a general antiderivative. All right, let's look at an example. So these are going to be about 1 line, so I'm just going to do it down here. Examples. All right, so the derivative, d dx, the derivative of, I can make my 5 look better, 5x squared. There's a little bit of talking. I'd like us to be quiet while we're taking notes and pay attention. 5x squared is equal to, all right. So again, the steps were multiply down, so this 2 got multiplied down into the 5, and that becomes a 10. I still have my original x, and this 2 got subtracted by 1, minus 1, and it becomes a 1.
Do we need to put the 1?
You don't need to put the 1. All right, so let's go backwards, and here we have our new symbol, the integral. It's like a stretched out S, and it actually is an S because it's an infinitesimal sum. I'm summing up something, and I'll talk about that later, especially when we hit graphs. The integral of, well, let's take that 10x. 10x.
I don't know how to do it.
You'll get better, I promise. Just make it a stretchy S.
Sophia.
You first take the derivative and then you do the antiderivative?
No, I'm just showing you, this is how you take the derivative, this is how you would take the antiderivative. Look how they match. I'm just keeping it with my columns.
Okay.
All right, so 10x, my steps were add 1 to the exponent. So this, I'm going to, it used to be a 1, right? And I'm going to add 1. My plus got messed up there. I'm going to add 1. So now this is a 10x to the power of 2, and then divide down. I'm dividing by that power. Divide by that power, so I divide everything by 2.
But then do you keep that power up there?
Yep, you leave that power up there.
Oh.
So this simplifies to what?
5x squared.
Oh, look, that's what we started with in our original problem.
Wow.
Are we done?
No.
No. What do we need to do?
Add a
Add
C.
C.
Add a c. There it is. Because this could have been 5x squared plus 2.
Oh, you literally add a C.
You literally add a c. That is the answer.
Something else.
Yeah.
That c could be a positive. It could be a minus. You could even write minus c if you were being a little quirky, I guess. But it's the same thing. You have some constant that you're adding out there.
Yeah, I know, I'm getting it.
And I totally forgot to talk about this, but where are we in our unit? So, Unit 5, we are in the first lesson. We have 9 lessons in this unit, so very similar to the size of the previous units, but there's a lot. In each of these lessons, there's quite a bit of stuff to talk about. And we are on standard L, antiderivatives. Eventually, we'll get to the definite integral. This just means I plug in numbers. These are without plugging in numbers. These are plugging in numbers. All right.
Yeah. That mentor guy of yours, do you have to pay him for all this? Like,
He does it for free because he's so awesome.
Aw.
Dang, that's super cool.
Do you think he's ever gonna
he
come
could
to
like
us?
make bank?
He might be coming down here. We're planning it out.
So like when we were at the conference, he said that like he really wants to come help us like the week before the or like one of the weeks before the AP test and like Mr. Simmons wasn't here, so that he can like get us like pumped up.
That's
like,
so
he's, like,
fun.
So then like he even put it on his calendar because like we were like yeah like that would really help us. That's so like
Mr. Sindel, yeah,
cute.
that'd be super cool.
Like I feel
you
like
and your baby can join us.
Yeah.
Yeah. When are we gonna get to meet your baby?
I don't know. It's my first,
He's like,
so
"You don't
I don't
baby."
want it in the outside world until I know it's going to be safe.
All
All right, so let's talk about some slightly more difficult antiderivatives. All right,
This is
so
not gonna go onto 2 pages, is it?
we're basically done after we talk about this slide, so it'll probably end right around there-ish. All right, so let's talk about the radical. Do we remember how to deal with radicals? If I was taking the derivative, what would we do with radicals? So, for example,
What is a radical?
ooh, what is a radical?
Slightly.
Slightly more difficult antiderivatives. So let's say I was taking the integral of, and I'm going to be super formal now, in parentheses, negative 2 square root of x. Radical is a fancy word for square root.
Oh, right, radicals.
Radical, man. And dx. Mr. Sindel, what the heck is that dx?
It's just X.
So dx, this is special notation that says this is the width of each of the infinitesimally small rectangles that I'm summing up to get backwards. For now, I'm just going to tell you guys, don't worry about it. That dx is just going to go away. So for now, the dx, write that in there to be formal, but when it comes to actually taking the integral, it goes away. Don't worry about it. I'm just writing this to be formal. We'll talk about this at another time. For now, I just want to get the operation done. You need to write it. You need to write this exactly. Get used to writing dx. That is formal notation when I'm going and taking the integral
Of a radical or of any?
of anything. In fact, if I was trying to be super formal up here, I should have written 10x dx. Everything in here should be multiplied by dx. That's why I had to put parentheses around here. All right. So, how do I do the antiderivative, the integral of this?
We're gonna do +1.
I need to rewrite that radical a different way, just like I would do if I was taking the derivative.
Oh, X.
Not quite.
one
Oh,
half.
you're already skipping ahead. Yeah. So this is going to be x to the 1/2 dx. All right. Now I do my rules. This is just powerhouse. All right. So when I take the derivative, I no longer write the integral. So powerhouse. What are the inverse rules of powerhouse?
You add 1, so it's gonna be 1/1/2.
1 and 1/2 or
1/5.
3/2.
Or 3/2.
Leave it as a fraction. This will make it much easier for us. 3/2.
You would multiply by 2 and divide by 3?
Exactly. So I need to now bring this down. I need to divide by a fraction. So if I'm dividing by a fraction, you can, and here's some notes on the side that we can put to skip some steps. When I divide by a over b, that is the same thing. These can go forward or backwards. It's the same thing as multiplying multiplying by b over a.
So we multiply by 2 over 3.
Exactly, yeah. So I'm going to multiply here by 2/3.
So first you add 1 to the exponent and then you divide up. Or divide down, sorry.
And then divide down, exactly. So from here, this is going to simplify to, and by the way, I should have put parentheses around here to let you know I'm multiplying. This 2/3 times this is going to be negative 4/3, and I'll leave it as x to the 3/2.
Yeah.
All right, are we done?
Right? Oh, plus C.
There it is, plus c. Don't forget the plus
So
c.
where does the dx go?
The dx goes away once I take the integral. I took the integral doing this step, so there's no more dx. The integral of dx is technically 1.
Okay.
I'm not 100% sure about that. I might have just lied to you. Anyway,
Okay.
Is it because, like,
Never
since
mind.
you multiply by d over dx, and since you're going reverse, then it flips?
Reverse.
yeah, it's the reverse of a
Why?
derivative. Reverse of a derivative is back to normal, I
Did
guess.
you guys ever have optics?
All right, let's talk about
Wait, what's
quotient.
Why are you looking at her like that?
Quotient.
I was like, I was trying to like.
All right, let's do the integral of 3 over x squared.
Toys and like talks to you.
And don't forget your dx.
Oh, my cousin.
Yeah.
All right, tell me what to do, girls.
Really? I'm not
So, I've
low D high.
Like my
Just kidding, I don't know.
So you do
Unwrap.
plus 1.
Nope. Something before, just like we did something
you
before
have
here.
to get the x on top.
Exactly. We
So-
don't like fractions because then, as Rosalie said, it would be quotient rule.
So we don't want quotient rule?
And you can't actually undo quotient rule,
Oh, okay.
as far as I know. You have to do some trick like this where you get rid of the fraction.
So 3 times x then negative 2.
Yeah, so this is going to be 3x to the negative 2. Still have my dx because I haven't taken
I
the,
do not know how to
the
do
antiderivative.
I feel like mine just look like normal x's.
All right. And then from here,
this. Yeah, I do.
what do I do now?
Now you add
Me.
1.
Okay, so what is it going to be?
It's gonna be negative 1.
3x to the negative 1. And then what do I do?
Multiply
Thank you,
down.
I know.
And then not multiply down.
You divide down.
Divide down is the opposite. So if I divide everything by negative 1, no more dx because that has gone away after I take the integral, after I've taken the antiderivative. And my final answer is
Negative x on 3.
so negative 3. And you can leave the x on the bottom. I'm just going to leave it on the top for now. Negative 3x to the negative 1
Plus C.
plus c. Don't forget that plus c. I guess I should have written it there too.
Yeah, boy.
All right. And the third and last part of our notes. Let's switch back to blue here.
Oh, yeah. We got a room.
Combo breaker. All right. So
Combo.
let's do this one. The integral of
I don't think I ever.
negative 1 over
Me.
square root of x dx.
I feel like it'd be really good. Now I just want to go get gumbo.
Do you guys know the combo breaker? No? You have to play more video games, I guess. All right, so rewrite this one.
Pass.
Isn't that Street Fighter?
It is, yes. Oh, thank you, Joy. That made my day. All right, rewrite this a different way. How do we rewrite this?
Negative 1 times x to the negative 1 half.
Negative 1x to the negative 1/2, exactly. Don't forget that dx. Being formal. If I was being informal, I would leave off the dx and a mathematician would come in here and, I don't know, kick me or something. He would not like me.
What about because he knows I'm not a mathematician.
Do you consider yourself a mathematician?
Oh, definitely, yes. I have math for fun almost, well, whenever I have time, I guess.
But you also game.
Not as much. All right, so from here, what do I do?
Add 1.
Add 1. So I have my negative x, negative 1x. I guess I can just write negative x. Negative x to the power of 1/2. Do we all see that?
Yeah.
All right. And then what am I going to divide by?
1/2.
Okay, so this is really doing what?
Times 2.
Yeah, we're really multiplying by 2 by dividing by 1/2. And am I done?
No.
Plus c. So our final answer becomes
Negative 2x 1/2 plus.
negative 2x to the 1/2 plus c.
You got rid of your S.
Was that the final one?
Yeah, once you get rid of the s, that's because we're taking the antiderivative. We're taking the antiderivative. Once we get rid of the s, we add a c.
Okay, sweetie.
So these are really basic, and I emphasize that because this unit is going to get hard really quick. We're going backwards with everything that we've done so far.
And you expect us to remember it?
Yeah, I do.
You think we'll be able to?
Yes, I think you will. All right, go ahead and write your summaries. That concludes the video.